Lesson 50, quadratic equations and completing the square. A quadratic equation is an equation in which the unknown has the number 2 as the highest power. It would have the number 2 as an exponent. So we define a quadratic equation as an equation in which the unknown, or the variable, has 2 as the highest power. We've been doing problems with the quadratic equation for quite some time now. There are 3 steps in order to solve, and we're just going to review these very quickly. Step 1 would be to factor. Step 2 is to set each factor to 0. And step 3 is to solve for the variable. For example, if I had an equation that was x squared plus 5x minus 36. This is a quadratic because the exponent here is 2, and that's the highest power. This x here is an understood exponent of 1. This doesn't have a variable at all. So our highest power to our unknown is a 2, which makes this a quadratic. All we do when we solve these is we factor. Okay, so if I'm factoring this, my first term is going to be x. And then I'm looking for terms that multiply to give me 36, but add or subtract to give me 5, and that would be 9 and 4. Then we write our signs accordingly. We set each factor equal to 0, so x plus 9 equals 0, and x minus 4 equals 0. And then we solve for the variable. So in this case, x would equal negative 9, and x would equal 4. Okay, so that's solving a quadratic equation. Just a quick review. The next thing we're going to talk about is completing the square. Before we get to looking at some of the problems that I have up here on the board, we want to talk about what completing the square is and why it's useful. A lot of times we get quadratic equations that cannot be factored. They're unable to be factored completely, or there are no terms that multiply to give us the last term that would add to give us the middle term, so we can't factor it. We can rearrange any quadratic formula to equal something that looks like this, x plus a squared, where a is a real number, equals k. We've solved problems like this before back in lesson, it's either 47, 48. What we did to get rid of the square is we square rooted both sides. We had something like this, where we'd have to solve for x. In order to get to this point here, we need to do something that is called completing the square. There are a few things we need to remember in completing the square, and to help you remember this, I've got a few examples up here on the board. To complete a square, it's necessary to remember the form of a trinomial that is the square of any binomial. So let's just look at a few of these. If I have x plus 2, and I take it over here and I square it, and I'm left with x plus 2 squared. Well, if I was to factor this, or distribute this out, I would end up with x squared plus 4x plus 4. Same thing if I did x minus 5 squared. I would distribute it out and I'd get x squared minus 10x plus 25. Same thing with the following each of these. Now, there is a pattern that we should notice in each of these problems, and that is this. If we take the middle term, in this case, in this one it's 4. If we divide the middle term by 2, and we square that, it's going to give us the last term. In this next equation, if I take the middle term, which is negative 10, and I divide negative 10 by 2, and I square it, I'm going to get the last term. This pattern follows all the way through. 12 divided by 2 is negative 6. Negative 6 squared is 36. 16 divided by 2 is 8. 8 squared is 64. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So this pattern follows all the way through for any time that we're squaring a term to get a trinomial. It just happens. There's no real explanation for it. We're just going to remember this pattern and we're going to use it in order to complete the square. All right, we're going to walk through an example, but I'm also going to give you steps to kind of help you figure out what to do. So we'll have steps on one side while we work this example problem on the other. And this is what our first example is going to look like. X squared plus 6x minus 4 equals 0. All right, so the first step is to get all of the variables on one side. So every term that has a variable is going to be on one side. Every other term, every other constant is going to be on the other side of the equation. All right, so step 1, all variables on one side, all constants on the other. And a constant is just a number without a variable term. So in our example equation over here, we're going to keep our variable terms, x squared and 6x, on this side of the equal sign. We want to move the constant to the other, so we're going to add 4. If I add 4, I get x squared plus 6x equals 4. All right, step 2. Step 2 is the rule or the pattern. We're going to implement it here. We're going to divide the middle term by 2 and square it. So step 2 is to divide the middle term by 2 and square it. So in this problem, our middle term is 6. So we're going to take this 6 and we're going to divide it by 2. Well, 6 divided by 2 is 3. And then we're going to square 3 and we get 9. Okay? This is our middle term pattern. Okay, we end up with 9. Now, what we're going to do with that 9 is we're going to add it to both sides of the equation. Add number found in step 2 to both sides of the equation. So if I add 9, I'm left with x squared plus 6x plus 9 on one side. And I'm going to add 9 to this 4, and I'm going to get 13 on the other side. 9 and 4 is 13. Okay. Now notice we have a trinomial term, and this term can be factored. So all we're going to do for step 4 is to factor and solve. If you need help on factoring and solving, you can refer back to, let me look here, back to lesson 45 or 48. So if you need help, go back and look at lessons 45 or 48. So what we're going to do is we're going to factor, first of all. We have x squared plus 6x plus 9. X is going to be our first term. And 3 is going to be our last term because 3 times 3 is 9, 3 plus 3 is 6, and they're both going to be positive. Now notice, when we factor something, when we're completing the square, we're always going to end up with the same exact terms in each binomial. So each binomial expression is going to be the same, which means we can rewrite this as x plus 3 squared equals 13. From this point, we're just solving for our x. In order to get rid of the square term, we take the square root. And what I do to one side, I have to do to the other. So I have x plus 3 equals plus or minus the square root of 13. And to solve for x, I subtract 3 from both sides, and x equals negative 3 plus or minus the square root of 13. And that is completing the square. That is your final solution. Let's take a look at another example. This example is 2x plus x squared minus 5 equals 0. All right, so we're just going to follow our steps, working our way through this. Step 1, we need all variables on one side, and all the constants on the other side. Also, it would be very helpful when your variables are on one side of the equation to make sure that they are in descending order. All right, so in this side, I'm going to have x squared plus 2x, and I'm going to add this 5 to the other side. Now my variable's on one side, and my constant term is on the other. Step 2, we're going to look at our middle term, which in this case is 2. We're going to divide our middle term by 2, and then we're going to square it. And 2 divided by 2 is 1, and 1 squared is 1. Step 3, we're going to add that term found in number 2. We're going to add it to both sides of the equation. So I'm going to add 1 here, and I'm also going to add 1 here. So I have x squared plus 2x plus 1 equals 6. And step 4 is to factor and solve. So what I'm going to do is I'm going to factor x squared plus 2x plus 1 to 2 binomials. The first term is x. And my last term is going to be 1, because 1 times 1 is 1, but 1 plus 1 is 2, and they're both going to be positive. Notice, again, each binomial expression is the same, so I can rewrite this as x plus 1 squared. And from there, we solve for the variable. In order to get rid of that square, we square root. And what I do to one side, I have to do to the other. Make sure you add that plus or minus in there. And then to get the x by itself, we just subtract 1. So x equals -1 plus or minus the square root of 6. All right. This next example, I want you to try on your own. X squared equals 5x minus 5. Go ahead and try this one on your own, and we will go over it in class.